Okay, so number 7 for the related rates problem. Suppose you drop that a drop of mist is a perfect sphere that through condensation, the drop picks up moisture at a rate proportional to its surface area. Show that under these circumstances, the drop's radius increases at a constant rate. Okay, let's go ahead and throw the answer up just so we have it. Okay, so show under these circumstances, the drop's radius increases at a constant rate. Okay, so they didn't give us any formulas here, so we're going to have to come up with a formula ourselves. First thing is the question, a sphere has a volume. Let me go ahead and make this editable markup. So we know the volume of a sphere is 4 over 3 pi r cubed, okay? And that the surface area of a sphere is 4 pi r squared. It's kind of weird, but it's just really 4 circles. Now, let's read this. Suppose that a drop of mist is a perfect sphere and that through condensation picks up moisture, so it picks up volume at a rate proportional to its surface area. So, So let's go ahead and take, so they're trying to show that this is true. So they want us to take the derivative dv over dt and show that this number is in that derivative. So let's go ahead and try it. Let's go ahead and take the derivative of this right here. So what's the derivative of 4 over 3 pi r cubed? That's 4 over 3 pi. And the derivative of pi cubed is 3r squared dr over dt. Bobby, are you okay with this? We took the derivative of v, and we're going to show that this equation here is actually hidden in there. Let's simplify dv dt. The 3's divide out, and we're left with 4 pi r squared dr over dt.
Okay.
Okay, and that's all they wanted us to do. So this is our surface area, dv over dt is our surface area multiplied by some constant, some changing value, some proportion, not proportion, some constant value. Okay? So that's why they end up calling this k. And it is true. So the drop picks up moisture at a rate proportional. Proportions are some constant multiplied by your number to its surface area. So yes, some constant or some k value. And this is my surface area. Yeah, that's right. Okay, on the left, it says the length of L of a rectangle is decreasing at a rate of 5 centimeters per second. So dl over dt is negative 5 centimeters per second. While the width is increasing, so dw dt is increasing at a rate of 5 centimeters per second, where L is 8 and W is 15 centimeters. Find the rate. Give me a second. Okay, and find the rate of the change of area. So they're looking for dA over dt. Right? So one thing we want to realize is this is a rectangle, and we have a rectangle equation. A is equal to length times width. Okay, and then determine which quantities are increasing and decreasing. Okay, so they want us to first find the rate of the area changing. So how to get from A to dA dt? What do I do, Bobby?
Take the derivative.
Yeah, so we take the derivative. dA over dt is equal to product rule dl over dt, leave w alone, dw over dt, leave l alone. Now, do we have most of these values? Yes, we have dl dt right here. We have w, we have dwt, and we have l. We have all those values to plug in. And when I plug them all in together, we have negative 5 times 8 plus 5 times 15. That is negative 40. This is plus 75. And we end up with, that's weird. We have I have positive 35. How come they told us?
Then it's supposed to be negative.
Well, one of these are negative, but I got the rate is decreasing. That's a negative.
But you put it equals to positive 35.
Yeah, I know, but isn't 15? Oh, I know. I plugged in the wrong numbers, guy. Look, I plugged in W is negative. W is 15, and L is 8. I copied the wrong numbers. I flipped them around. That's why. And we can see that this is negative 75 now. Sorry about that. And this is 40, and then we're negative 35. And that's dA over dt. Okay, that's what they want to hear.
Okay.
Now the question is the area increasing or decreasing or constant? So Bobby, what do you think? The rate is negative 35.
What does it mean by constant?
Constant means actually not changing. And if you saw constant, this would be 0. dA over dt would be 0.
Decreasing.
Decreasing, good job. What rate is the perimeter changing? So that's the different question. So how do you come up with the equation for the perimeter? Let me draw this out. It's let's call this width, length, width, length. So the perimeter is equal to 2L plus 2W. How do I find the rate that perimeter is changing?
Right. You just do the derivative.
Yeah. So we do the same thing we did before. We said dP over dt is equal to 2 dl over dt plus 2 dw over dt. And they gave us dl dt and dw dt already. That's 2 times negative 5 and 2 times positive 5. And guess what? They cancel out to become 0. So is the perimeter changing at all?
No.
No, because the change is 0. So it's constant. And then last question is, what is the rate of the diagonal? So how to find this diagonal? Remember, this is a right triangle. So what equation relates the sides of a triangle to its diagonal?
Wait, what does that have to do with triangles if we're doing a rectangle?
This part right here, this last question. The rate of the length of the diagonals of a rectangle. So the diagonals of a rectangle, doesn't it make into an easy triangle?
Would half of a rectangle be just a triangle?
It would be. If I cut it by its diagonal, yes, it would be half. But for us to relate the sides of this triangle is actually Pythagorean Theorem. W squared plus L squared is equal to D squared for the D diagonal. Okay, so to find the rate of the diagonal changing, we're going to take the derivative to W dW over dt plus 2L dL over dt equals to 2D d over dt. They gave us some values. They told us that the sides of the triangle was, the width was 15 and the length was 8. So I need to find what D is. See how we need to find what D is? We have this, and this, all these values. 2 times 15 times the width is 5 plus 2 times 8. The change is negative 5 equals to 2 and D. We don't know what D is. We have to know what D is. So Pythagorean Theorem.
What? Okay.
15 squared plus 8 squared equals to D squared. That's going to be 225 plus 64 is 289 equals to D squared. don't know what 289 is.
But then you don't know what D is.
Well, that's what we're looking for right now.
Oh.
And this is actually 17. Wow, that was actually 17. I guess that's a Pythagorean triple. I didn't know. So we know this is 17 now. And we just have to solve for our diagonal. Okay. Add these up. That's 10. What's 150? That's 10 times 8 is 80, so negative 80 equals to 2 times 17. D over T. We're going to move that over, divide it over. So that's going to be 70 over 34 is equal to dd over dt. Okay. And 17 over 34 is 35 over 17. Now, is this rate increasing or decreasing? If this is a positive 35 over 17.
Is it increasing?
Increasing, that's why they were increasing.
Wait, why is it?
Okay, so for this is homework number 26, question number 11. A rectangle whose hypotenuse is square root of 13. Okay, so we know the hypotenuse is square root of 13 meters long, is revolved around one of its legs to generate a right circular cone. So we look at a triangle, and we're going to revolve it around one of its legs. And it's going to make a cone here. Okay. Now, it says find the radius and height of the cone. Maybe we'll spin it the other way, probably. We probably want to spin it this way instead. I spin it this way. Okay, because they wanted the radius and the height. And find and volume. Okay, find the radius, height, and volume of the cone of the greatest volume that can be made this way. All right, so we want to optimize the volume, okay, greatest volume. So let's write down the volume equation for a cone. The volume equation for a cone is 1 over 3 pi r squared h. So the hint about these optimization problems is they always want you to optimize something. So that's the key formula we have to do to write it out. And the volume is what they want me to maximize here. And they asked me for the radius and the height. So I have these variables that are going to be given to me. Now, just to spin this around, we know that the hypotenuse must be square root of 13. Okay, this is my hypotenuse. The square root of 13. Well, square root of 13 could be made up of triangles that were lower, right? Or triangles that were higher. Okay. But which of these would maximize my volume? I don't know. Imagine if I had a really low to the ground cone, right? If I had a really low to the ground pancake style one, would that give me the greatest volume? Or a really sharp cone up here, would that be my greatest volume? And that's the question. And our goal is to figure out which combination of the two of our height and radius, but still giving us a square root of 13 would help us out here. Now this would be my hypotenuse, and let's call that, usually we use the letter H, right? We'll call this D, let's say D, okay? Now, we could take the derivative of this right now, but I'd rather not. I'd rather be able to substitute maybe something in here that would help. We know that the D is a constant. So let's see. We can relate these three sides using Pythagorean theorem. R squared plus H squared equals to square root of 13 squared. We know for sure that is true. So why don't we use that as our hint to substitute one of these variables out? I'm going to find the maximum volume of a cone. Okay, so let's go ahead and try this. What if R squared plus H squared is equal to 13, and R is equal to 13 minus H squared, and that's gonna be the square root. Okay, the reason why I did this is because when I plug it in, we're still gonna end up with a not square root. So V is equal to 1 over 3 pi, And then our R value is going to be replaced with our square root. And the square and the square root are going to cancel out h. Okay, I'm going to multiply this out one more time. We have v is equal to 1 over 3 pi left over 13 h minus h cubed. Okay, so we're going to go ahead and now take the derivative of this. The derivative dv over dt is equal to 1 over 3 pi. That's going to stay. And then let's go take a derivative of this binomial. It's going to be 13 minus 3h squared dh over dt. Wait, would we take... would we use a rate? This isn't a rate problem though. So we're not going to use dt. Let's use it in reference to dh. Would that be smarter? No, we would just take the derivative with respect to what? Take the derivative with respect to dh over dt. Is that what I want? Let's try it. We'll just say dh over dt. So it's just going to be h squared. We make this go to 0. So volume is equal to, volume is changing in reference to h at 1 over 3 pi. And we're going to make this go 0. So when does this guy go to 0? 13 minus 3h squared equals to 0. We minus the 13 divided by the 3. H squared is equal to 13 divided by 3. H is equal to plus and minus the square root of 13 over 3. Now, that's my h value here. H is equal to square root of 13 over all over the square root of between 13 and 3. And if I know that is my height, okay, so also now, is that clean enough? 13 goes to 0 at square root of 13 over 3. And the slope changes from, as actually it's bigger, this is going to be a negative and a positive. Because if I pick a number bigger than this will become more negative. So our volume would be decreasing, and on our left would be increasing, okay? Now let's go back and solve for, if we know our value, that is r is equal to the square root of 13 minus h, which is 13 over 3 squared. Square root, those will cancel out, leaving me a r is the square root of 13 minus 13 over 3. Common denominator is 3, so that's 39 minus 13 is 26. So square root of 26 over 3. Square root of 26 over 3. So this is my radius and my height. That'll give me my highest volume. So what is the strongest volume? If I plug it back into volume equation, V is equal to 1 over 3 pi. And I'm going to plug in the radius we said was square root of 20 over 3 squared times square root of 13 over 3. Okay, let's see if this is the answer. Oh, they changed the answer on us, darn it. But it is 21. If we can get back to the answer we got. 20, 11, 12. Ours was 13, right? Come on, get to 13. Oh, that was 13, but it didn't give us an answer to 13. Oh, I can just hit some of the question on here. There it is. So the radius was square root of 26 and over 3. Is that what we got? I don't remember. No. Okay, yep, that's our answer here. We got square root of 13 and 3 and square root of 26 and 3. And then, but our final volume is this craziness right here, right? Okay. I'm going to take that as a yes.